Okay, so trig equations and identities, I mean, it would help to know what those two words are. In some ways, they're the same thing. Solving equations, you know how to solve equations. You've solved equations before, lots, probably starting grade 7. You started with simple ones in grade 7, like x plus 7 equals 10. What does x equal? And a lot, you know, that's the pretty basic part. Just realizing this stands for an unknown number. It's still the same thing, except there's other operations other than just adding, subtracting, multiplying, and dividing. There's trig functions in it, but still the concept is the same. You're trying to figure out what the variable is. Now, the fact that there's trig functions in it, if you think about the graph of trig functions, since they're repetitive, there's going to be an infinite number of answers for these things, unless we restrict it to certain values. When you had a number like, when you had equations here, linear equations, there was one solution here. X is 3. There's only one value there. For trig equations, there's going to be lots of different things. Some of them are going to be ones that you can solve algebraically. Some of them are ones you can't solve algebraically. The ones, all the stuff you did in earlier grades, you solved algebraically. You never solved it another way. You could solve equations lots of different ways. If you really wanted to here, you could. I mean, it'd be kind of a waste of time for this because you can see what the answer is. But you could graph this and then just look where it's equal to 10 and figure out what value it is. All right, like you could graph x plus 7. X plus 7 is well, if that's a line. If you graph y equals x plus 7, it's got a y-intercept of 7 and it's got a slope of 1. And then if you looked at where it's 10, it's going to be 10 right here somewhere, and that would be 3. That would be solving that graphically, as opposed to what you did. You never solved it graphically because when you learned about equations like this, you didn't even have a concept of what a graph was. You solved it algebraically. You used inverse operations. You did that, right? And you just worked your way down. You could solve it graphically because for a lot of these, that's going to be the only way you can solve them is using a graph. Is who knows what, you know, how to solve this thing algebraically. But what you could do is you could graph this and graph this. Like you could go y1 equals this, y2 equals that, and you want to know where they are equal to each other. Who knows what they look like? Maybe one looks like it's got tangent and cotangent, so it's probably going to have some crazy asymptotes, but whatever it looks like. And then the other one looks something like, I don't know what it looks like, but something like this. The solutions are going to be where they're equal to each other, where they cross. Okay? You could have done that in grade, well actually in grade 11 you did do that. You solved, you looked at two variable equations, and you know, if you had two things like this, you graphed them both and found where they intersected. That would be the same as solving this equation graphically. 2x plus 1 equals 3x minus 5. If someone asked you to solve that graphically, one way to do it would be to graph this as one function, graph this as another function, and find where they cross. So solving algebraically and solving graphically are different things. You can solve any equation graphically as long as your calculator understands those operations involved. So that's why the first thing we're going to do is solving graphically with technology. It's kind of tedious to do it without technology. There's going to be, I mean, we're focusing on trig equations, but you could do anything, right? And then we're going to look at some algebraic methods of solving. These methods themselves you already know. You know isolation, it just means getting the variable by itself, right? What you did, you know, with this grade 7 equation here, you got x by itself. And then later on you learned some other things, how to factor. If you had a quadratic function, you couldn't isolate it. If it said x squared plus 5x plus 6 equals 0, you can't solve that one by isolation because you have x squared and x. So what you had to do is you had to learn another method. And one of the methods was factoring the thing, and as soon as you factored it, you could look at what x is, or you learn the quadratic formula. So we're just going to apply that now. The only difference here is it's going to say sine x squared plus 5 times sine x. I guess I could write where there's actually some space. Wouldn't that be good? You're going to be able to do well at this if you make some connections with what you already know. if someone, if you see an equation that says 2 sine squared x plus 5 sine x plus 6 equals 2 sine x minus 7. If you want to solve that algebraically, you think about the things you know. You learned a long time ago about like terms. You have, just like before, without, if this wasn't here, if you had 2m squared plus 5m plus 6 equals this stuff, 2m minus 7, you would know how to solve that, or at least how to start. Right? You gather all the things on one side, you put terms together that go together, and you start trying to isolate it. Maybe you factor it or use a quadratic formula. It's going to be exactly the same for these kind of things, except that what you're solving for is not x, it's sine x. And eventually you'll get sine x equals some number, and then we can figure what angles that is. So there's a lot of connections you have to make to do that. The other thing involved in this unit is trig identities. An identity is a statement that's always true. You could make up some identities that don't really tell us a whole lot, like 0 times any number is always equal to what? What's 0 times any number always equal to? 0, right? Or 1 times some number is always equal to the number, right? These are identities that, what it means is it's a true statement for every value of the variable here. That's what an identity is. Now we're not going to do such identities like this because they're not very interesting. We're going to look at identities like, well, you know some here already. You know some basic identities just because that's definitions. Cosecant of some angle by definition is the reciprocal of the sine. This is an identity that's true for every value of the angle, except there might be restrictions here on the variable, but we'll get into that later. There was one that you know that tangent of theta is always equal to dividing 2 of the other functions. What's it always equal to? Anybody remember? Well, tangent happens to be always equal to, if you when we looked at a unit circle, if you have x and y here, if this is a unit circle, sine is y, cos is x, tangent is y over x, but since sine is y and cos is x, and this is y over x, tangent's always equal to sine over cosine. For any angle you pick, other than an angle here for which this is undefined, where the bottom's 0, this is an identity that's always true for everything that it's defined for. What you're going to do with these, you're going to start with some basic identities, and you're going to use those to prove other identities. Okay, I might tell you that 1 plus tangent squared is always equal to secant squared. This is an identity that says this is always equal to this, and what you're going to be asked to do is prove that that's true using what you already know. Okay? So that's where this identities stuff is going. This takes practice. This takes a lot of practice. The equation stuff is probably easier to get by not doing quite so much. Because once you do a few solving a quadratic, if you're good at kind of memorizing the recipe, you can get it. But this stuff takes a bit of practice. Okay? So that's where this unit is going. We're going to really quickly look at this first one, and then you can either get started on that, or you can work on old stuff if you'd rather do that. All right?